Hey YouTube, Sokyo here, and have you ever become entangled with anything in the past? Well, you may have been entangled in a different way without even knowing it, that wasn't actually physical and that you couldn't see or notice. And this is quantum entanglement, and it all has to do with elementary particles. Elementary particles are the smallest objects in the universe, things like electrons, neutrinos, bosons, and muons. All of these are some of the smallest objects in the universe. And they have a weird property. If you aren't looking at them, then they evolve, which is basically how they change through time, like a wave. They spread out generally, and you do it using this equation called the Schrödinger equation, and that is used to define and discover how they'll move. It's almost like taking a ball that's in the air, looking at its current position and looking at its inertia, its energy, its direction, to figure out where it will be in the future. But the thing is, when you look at these objects, you don't see them as waves, you see them as singular points in space-time instead of these spread out areas that and where there's a probability of them being. You see them at a certain definite point in space-time. And this is a very interesting quirk of the universe. It relates to the famous thought experiment Schrödinger's cat, of course, about looking at something versus not looking at something. And there are lots of interesting things about this, such as how there's a theory that suggests that this shows that there are parallel universes out there, i.e. one where the particle is like it is when we aren't looking, and one where it is where we are looking, to make it simplified. But there's another interesting fact about these, which is quantum entanglement. So if you shoot two elementary particles, even though they're waves, as I said, without looking at them, at each other, like two electrons, they bounce into each other. But the weird thing is, after you separate them, if you collapse the wave function of one of them, i.e. looking at them, it will collapse the wave function of the other one. It will turn it from a wave to a point in space-time, and this will happen no matter how far apart they are, and it technically happens instantly, because by shooting these two objects at each other, these two elementary particles at each other, they become linked through quantum entanglement, where the state of one of them is influenced directly by the state of the other one. And it's technically a way to travel faster than light, but it's not traveling any matter that would ever be useful to us. It's just changing this, it's almost sending a signal out faster than light. And that is what quantum entanglement is. And although it's very unlikely that it actually happens with you, because all of the electrons and other elementary particles are contained inside your body, you could have technically, without even knowing it, become entangled with another elementary particle.